Welcome to lesson 2 of rates of reaction for year 10. We're having a look today at the factors that affect the rate of a chemical reaction and how we can explain that by using collision theory. We need to remind ourselves before we start this about what we mean exactly by collision theory. So we're going to build up a mind map. There's going to be 6 points coming off of this mind map, and I'm going to deal with the first one, which we're going to put at the top of our page. And that's for us to recognise that during a chemical reaction we have reactant particles, and I'm going to draw these as 2 different coloured dots. Okay, so we've got our 2 reactants, the black one and the red one here. And these are all moving around in a random direction. And when they move, there is a chance that 2 of them could hit each other with enough energy to overcome the activation energy. And remember, last time we called that a successful collision, and then they're going to make a product. So it's all about these collisions. So any factor that increases the chance of a successful collision is going to increase the rate of reaction. And rate of reaction is how fast the reaction is going. So it's quite an important idea there, that any factor that increases the chance of a successful collision is going to increase the rate of reaction. So we need to always have that in mind when we look at our different factors. So let's first of all look at temperature. Now, if the temperature is increased, and what that will mean is the particles have more kinetic energy. And we can say from that they will move faster. So from that, therefore, there will be a greater chance of a successful collision. So temperature is our first factor. If that's increased, then our particles have more kinetic energy and they move faster, and therefore there is a greater chance of a successful collision. If we were to think about drawing this as a diagram, it's not the easiest thing to draw, obviously, because we can't draw our particles as moving, but if we just draw these little lines here to represent the movement, so this would be at a lower temperature, and then at a higher temperature, more paths showing that these particles are moving randomly but faster because they have more kinetic energy. Okay, so the key idea there is that if we've increased temperature, the particles have more kinetic energy and they move faster. So this would be a low temperature, and this would be a high temperature. The other one that we're going to look at in this video is concentration. There are 3 other factors as well, but we're largely going to deal with those in separate lessons because we don't want to overload. So let's have a look at concentration in this one. So concentration is how many particles there are in a given volume. So if concentration is increased, there are more particles in a given volume. And that word given volume means just in the same volume. therefore, if there's more particles in a given volume, there is a greater chance of a successful collision. So let's have a look at how we might think about drawing that diagrammatically. So I'm going to draw a box, and this box is representing the volume that the reaction is taking place in, and we're going to have a box for a lower concentration and for a higher concentration. So here's our box for a low concentration. Low concentration means there are less particles in there. Don't forget that these particles are moving around as well, so I'm drawing these particle paths here to show that they're moving around. So this would be a lower concentration. As we increase the concentration, so we put more particles or more material into the volume, like this, then naturally there's going to be a greater chance of those particles bumping into each other, those particles colliding with each other, and a reaction taking place. So, concentration, if we increase it, that means there's more particles in a given volume, and therefore there's a greater chance of a successful collision. This diagram shows the particles in a low concentration, and this shows it in a higher concentration. So there are three other factors. Pressure. So pressure is very similar to concentration, so I'm just going to draw an arrow going from there, and that to say so pressure is similar to concentration, and also the explanation is largely the same. If we increase the pressure, so if the pressure is increased, then there are more particles in a given volume. The other two factors are catalyst and surface area. Of a solid, so surface area of a solid. These have separate lessons in themselves later in the course, and I don't want to add them to this mind map at the moment because it would add a level of confusion which I don't want to go into at the moment. So let's just review what we've had a look at. So it's key that we understand the idea of collision theory. Any factor that increases the chance of a successful collision increases the rate of reaction. I've just realised I've missed off the word collision there, so that was lucky that you reviewed that. So any factor that increases the chance of a successful collision increases the rate of a reaction. Temperature. If we increase the temperature, particles have more kinetic energy and they move faster, and therefore there's a greater chance of a successful collision at a higher temperature. Concentration. If we increase the concentration, there are more particles in that given volume, and therefore there is a greater chance of a successful collision taking place. So increasing temperature and increasing concentration both lead to an increase in the rate of reaction because there's an increase in the chance of a successful collision. And then we've got these two, the surface area and a catalyst, which we're going to deal with in a separate lesson. Thank you very much.